Okay, so last time we had pretty much finished up our discussion about some of the different cross-platform tools and some of the old scripting languages and things like that. So we kind of talked about all these different approaches to programming and how today more than ever we're in the situation where we have a whole bunch of different types of programmers all trying to target the same platforms. Okay, so the popular kids on the block today would be, your mobile phones and stuff like that. And now we're starting to get into areas of like wearables. So, probably over the next year or so, the popular thing is going to be smartwatches, right? That seems to be what everybody's coming out with now. We're actually going to have a class on smartwatch development in the fall. CSC200 is going to be kind of focused on Apple Watch, but kind of the idea of apps for smartwatches. So if you're interested in that, I encourage you to maybe consider the class. It might be a little bit rough from the programming perspective for you guys, but many of you will be in 250 concurrently and probably would do all right. So I'd encourage you to take a look at that. That's CSC 390. So in any case, we have a whole bunch of different types of developers, people with all sorts of different skill sets, all targeting the same types of platforms. And we need to have these tools in the middle that help them do that. And that's where I introduced this idea of a language called Blockley last class, right at the end. So we have something called Blockley. That's good. So Blockley is something that's made by Google. It's written in JavaScript. So it runs entirely in your web browser. Okay? So the idea is that if you want to, what I've done is I downloaded the Blockley project and then I uploaded it to one of my servers so that I could give you the URL and you can use it. But any one of you can go and download Blockley and just run it locally off your hard drive. There's nothing special about it. It's JavaScript. Remember, we talked about web browsers understand HTML and JavaScript. It'll run right off your computer. You don't need anything special to make it work. So if you want to do that, you certainly can. I think let's go to, just do Blockley Google. So it's Google.code or code.google.com/p/Blockley. Just do the search, whatever. Let's see. Oh, it's moved. So it's developers.google.com/Blockley. That's the address. And then down here, I think, is the download for it. So installation, get the code, and install it into your application. Let's click on that. Yep, here's get the code. So you can download a direct zip file, and when you do that, it's just going to give you a folder. And inside that folder will basically be the exact same directory structure that I've given you there online. I think it's going to be done shortly. So here's that directory structure. Inside of here we have our demos folder, and inside of there we have the code folder, and there's the index.html. So if I double click on that, it'll open it up in a browser. This is the exact same thing that you're seeing that I gave you the link for last time. Okay, just running right off your computer. All right. So in any case, you can go ahead and get that. Now, to tell you a little bit more about Blockley in general, so again, written by Google, it's written in JavaScript. It's not, even though the site that I've kind of set up is made for you to run your Blockley program within the site, I think I showed you last time, it actually exports to other languages. All right, so Blockley itself isn't meant to be a programming language by itself. Rather, it is meant to allow developers to graphically create their programs and have the source code generated for them in various languages that they can then drop into another application. All right, so that's what this tool's for. We're going to be using it largely for actually running programs graphically, okay? But really what the tool is for, this isn't like for teaching kids how to program. Okay, this thing is, by kids I mean, like 8-year-olds and stuff like that. There's a lot of tools out there that, have you following Hello Kitty and doing things like that. This would be a professional programming environment that's done completely graphically. But ultimately what it spits out is the equivalent code in some other language. So if we look, I think I did it doing it here. So notice that we graphically create it, and it gives us the JavaScript equivalent. It gives us the Python equivalent, and then the XML, don't even worry about that. I'm sure that's just how it represents itself behind the scenes, because remember, that's a data representation language. So if I ever ask you the difference between a programming language and a data representation language, what might you say? We'll just pretend like that was a quiz today. It's the difference between a programming language and a data representation language. Oh, that's been sitting too long. It just goes in for a second. Go ahead.
The data representation, is it just there, but programming, it actually does something inside of itself?
Okay, so programming languages do things. So we've defined programming languages as delivering for us a way of representing memory, asking questions, and repetition. Right, so that's kind of our simple case for programming languages. It does stuff that mimics the way we solve problems. What does a data representation language do? You say it's just there. What's its purpose? Its purpose, go ahead.
Make information look nice.
Okay. I think you're on a decent path there. It doesn't necessarily have a goal of making information look nice. I mean, like your web browser would interpret HTML, which would be a data representation language, to make it look nice. But the actual purpose of the data representation language would be just to hold data, to represent data, so to speak, right? So the idea is that it can't remember things, it can't ask questions, it can't do repetition, it's not doing any of our programming language stuff. All it's doing is it's taking a collection of data and putting it in some sort of format that is usable by a computer program someplace else. Okay, so programming languages often use data representation languages to send information back and forth, but they don't solve the same problem. Kind of make sense? So in any case, we can see that the blocks version of our program here, where I'm just creating a variable. So again, this fits the idea of our programming language, doesn't it? Where we have the ability to do variables right here. So I'm creating a variable named name, setting equal to Mike, and then I'm just printing it out. Okay. Here's logic. We have the ability to ask questions. So I could say something like, let's just delete that. I can put in logic and I can say if name, which I need to do, I actually need to do this. If name is equivalent to Mike, then what are we going to do? We're going to print cool guy. Oh, that's actually interesting. So the if only lets you do one thing. If you want to have the ability to respond to either true or false, you would use a test instead of an if. We'll look at that in a second. All right, so I can only test to see if it's something. So if I run this, name is Mike, I test to see if name is Mike, so it's going to display cool guy. There's cool guy. I change the name to Bob, and I run this, it's not going to display anything. Okay? Now let's just see if this functions as an else down here. I don't think it does. So if it's Mike, cool guy, and this only refers to males, so only males in here. If your name's not Mike, then you're a loser. All right, so let's see. I'm guessing that the way this is going to work is it's going to only say cool guy if Mike is up here, but it's always going to say loser. It'll say both things. So cool guy, and there's the loser, even though it was Mike. And if I change this to Bob, it should just do loser. Okay, so this guy only allows you to ask a single question, and if it's true, respond to it. As opposed to if we come in with a different type of logic here and do this test one. Looks like that should be... Let's see if this works. Name is equal to Mike. That doesn't work in there. How do we do an if else? Is it not built into it directly? So we'd really have to do something like if name, actually we need to have our logic. If name is equal to Mike, do one thing, and the thing we're going to do is we'll print something. We'll print name as Mike. Then we're going to have another if statement. If, I'm actually going to steal this whole thing. Name is not equal to Mike. We'll print name is not Mike. So I guess we have to kind of build our own if else. That's what it seems like it works to me. So if it's equal to Mike, do this. If it's not equal to Mike, do this. Oh, there we go. There we go. So you just click on this little dude here and change it to an else. And when we change it, actually we probably need to lose this to change it to an else. What's happening? How do I? Okay, there we go. Yeah, we have to build it into this. That's interesting. Okay. So really, I'm going to steal this. I'm going to kill this. I'm going to modify this. We're going to add the else to this guy. And then we can paste this guy up here. There. That should do it. So if name is Mike, print out name is Mike. Otherwise, print out name is not Mike. Right now, name is Bob, so it should print out name is not Mike. If I change the name to Mike, it'll print out name is Mike. Okay, so kind of how the logic works. But more importantly for us, just from understanding how this connects to our cross-platform tool stuff, notice that if we click on the JavaScript, we get, let me make this a little larger, we get a variable defined called name2. We initially set it to Mike. We ask the question if name2 is equal to Mike. Then we put up an alert box that says name is Mike. Otherwise, we put up an alert box that says name is not Mike. This is the JavaScript version of that code. Python. Start off a variable called name. This is defining it as initially being nothing. Then we're giving it a value of Mike. Name is equal to Mike. Do this, else do this. So we're seeing the exact same logic, but in a different language. That makes sense? And I actually just had a curiosity. Is Python? Yeah, it is. So there's that Python programming program running. Similarly, if I close this, exit, quit maybe. There we go. So there's the code. I just put it inside of a Python file. I called it I called it test.py. So I'll run that Python test.py, and there's name is Mike. That's because I had set the name to be Mike. If I change the name now to Bob, run the exact same program, now we get name is not Mike. Okay, so it's showing us that it's exporting to another language that now works. All right, when we run it inside the web browser here, it's always running the JavaScript version because web browsers understand JavaScript. So when I run this, when I hit the play button here, it's just going to go into the JavaScript and execute this. It's embedding it in that web page. Python is not something that a web browser understands, so we have to go external to the web browser to get it. I'm not sure if Python is natively installed on the Mac or not. I teach a Python class online, so it's possible I installed it. So if you have a Mac, you can probably try this Python thing, but otherwise you can download it pretty easily. Dart is another language that nobody really uses right now. So just another scripting language. And XML, like I said, is probably how it's representing. So this is an example of a data representation language. So this is probably how it's representing our blocks code behind the scenes. So this guy right here, which is probably a JavaScript program, is interpreting this XML document to draw this structure. That makes sense? All right, so that's kind of how Blockley works. Now, just to kind of go through here and see the different things we can do, kind of what tools are in our toolbox, and in this case, they actually give us a toolbox over here on the left. So for logic, we have the if else, blah, blah, blah. This is our ability to create Boolean expressions. What's a Boolean expression? Any expression that boils down to a single value of true or false. So we can ask if something is equal to, not equal to, less than or equal to, greater than or equal to, all that jazz. Okay, we can do ands and ors. So we can kind of build that together for our Boolean expressions. We can see if something is not something else. Here's our primitive for Boolean, true or false. This guy will support both true and false. That's for our Boolean primitive type. Null is to check to see if something does not have a value in it. I'm not sure what test, let's see, check the condition if test, in test, if the condition is true, returns, if true, okay. So given that, if I throw this guy out here, I then should be able to do this. If true, I should be able to do, actually, can I just grab the whole thing? Yeah, see, I can't print something. If true, you got to have something that branches off of here, and print doesn't have that left branch. So it must allow us to do some sort of other logic. So maybe setting a variable equal to something allows us to do it. So anything that has a little hook over here in the left on the puzzle piece. Yeah, so test seems a little bit strange to me, maybe. We'll have to come up with an example of when we can use that. All right, so that's our conditional stuff. So all this deals with asking questions inside of logic. Loops, this deals with our repetition, so we can repeat something 10 times. Go ahead and throw that out there. Let's kill this off. And this actually becomes a little bit, when I first messed with this, this actually was a little bit frustrating. I'll print blah 10 times. Okay, and if we look at the JavaScript code for this, here's our loop. We have a for loop. Start count off at 0, keep going as long as count is less than 10, increment count by 1 each time, and we're doing an alert box each time through. So this is literally going to pop up 10 separate alert boxes. There's 1, there's 2, there's 3, there's 4, so on and so forth. Now, one thing that you should know when you're messing around with Blockley is if you have pop-up blockers enabled, you may not get your output. So now, taking that exact same thing, though, if I go into here and I grab the Python code, the Python equivalent of this, and just go back out here and I edit that file. That's weird. Did I not? There we go. And then I run this. There's my blah 10 times. All right, so that's doing it much more like a typical programming language would do. That's kind of the difference between having to leverage JavaScript to run it within the browser, or taking the code that it produced and dropping it into a Python program like I just did here. Kind of make sense? Okay, so let's go back into here. So again, loops, we can repeat something so many times. We can do something as long as something is true. So while something is true or until something becomes true. So when we talked about the various types of loops that are in our languages, this would fall into our category for that. We can count a variable. So this is a variable I. You can name this whatever variable you want. So we can rename the variable or create a new variable. Starting from a certain number, going until another number, this changes it by that much. So if I'm going to steal this code, I'll start I off at 7, keep going as long up to 10. My guess is it's probably including 10 by the way this reads. So this will go 7, 8, 9, 10. I'm incrementing it by 1 each time. So it'll start at 7, then it'll go to 8, then it'll go to 9, then it'll go to 10. What am I doing each time? I'm going to print blah to the screen. So this should print blah less times. Similarly, though, I can print I. So I can print this variable I that it created for me. So now when I run this, it's going to print out there's my 7, there's my 8, there's my 9, and there's my 10. And it's done. Okay, look at the Python code for that. Starts, woo, hello. Anybody want a pizza? That's unfortunate. Trust me, the Python code would have worked. All right. That might be one small side effect to Blockley for us, is since we're not able to save that code as it currently sits right here. If you do that, you've lost everything. Kind of interesting. So I wonder, let me go into demos here real quick. Oh, it automatically goes back to that. Yeah, so there's ones that have a whole bunch of sine and cosine stuff. We're just looking at the simple version of it. It doesn't seem to have a save function that I can see. Although I wonder, can you go into code editor? Let me go back real quick. Go into the code editor. Can I write Python and have it spit it back to blocks? Doesn't look like it. Can I edit this though? I can edit that. So it seems like the way we would save stuff then is if I do an if statement like this. Let's see what this guy looks like. I can go into the XML here. I can copy that code. Then if I delete this, you'll see XML is now empty. I should be able to go in here and paste that code in, go back to blocks, and it's back. So you can actually save it by copying your XML over and over again. So that might not be a bad idea, I guess, as you're using this, is just have a notepad up that whenever you make a change and you want to save it, you just jump into the XML side of things, copy it, and paste it into a notepad and save. That way, in case your web page gets messed up like I just did, where I zigged when I should have zagged and it went to the wrong screen, I would be able to bring everything I'd done back. Okay, so there's our evidence there that the XML over here is the data representation language for blocks. So this guy draws in from that. All right, so again, our loops, we can do for each thing in a list. So we'll see lists here in a second. Well, here we can actually do it. Let me go into lists. So I'm going to create an empty list, but I can create some stuff. Here, this would be a good, I'm going to use that here in a second. We're going to create a variable. Change the variable name. So we're going to say rename. We're going to call this guy myList. And we're going to create this list. With Mike 5 times. So this will have a list of Mike 5 times. Okay. So I'll put that up there. So now I have this list. For each item I in the list called myList, and you can rename this if you want, but each time through I will be the next element in the list. I'll go ahead and print I. So this should print Mike 5 times. There's Mike, there's Mike, there's Mike, there's Mike, there's Mike. All right, now we should have the ability to add something to a list. We could find the first occurrence of something in the list. We could ask if something's in a list. Well, this would actually be a fun way to make our list. Put that in there. Get rid of that. We're going to put some text in here. So now we can build a list from text. We can also create text from a list. goes both directions. So I'm going to build a list from text, and the default delimiter is a comma, but you can change that to whatever you want. So I'm going to say cat, comma, dog, comma, fish. All right, so I have 3 elements in my list separated by commas. For each of those in my list, it's going to print it out. So this should print out cat, dog, fish. There's cat, there's dog, there's fish. So another tool that's in there in our toolbox. All right, so that's our for loop for going through every element in the list. We also have this idea of a breakout or continue. These are things from our modern programming languages. Breakout lets us get out of a list as quick as we can. So for instance, let me kind of just show you that. So for each element in our list, let me drag this print out of here. I'm going to ask a question. I'm going to say if I, except I need to get my logic guy up here. If this guy is equivalent to, let's do dog. All right, so if it's equivalent to the text dog, which is the second element in our list, then what are we going to do? We're going to break out of this loop, which will make the loop immediately end. Okay. We'll go ahead and add an else to this guy, and the else is going to be to print I. So for each element in our list, we'll ask the question, if I is equal to dog, then we're done with the loop. This will immediately exit us out of the loop and we'll be back down here. So I can come down here and print done. Something like that. Okay, so for every element in our list, if it's equal to dog, we're going to break out of the loop, which gets us past the loop, and we won't access anything else in our list. Otherwise, we'll just keep printing elements in our list. So if we go through our list here, we're going to hit cat. Is cat equal to dog? Nope. So print out cat. Then we're going to hit dog. Is dog equal to dog? Yes. So we're going to see done. And that's it. That's the only things it'll hit in our list there. So there's my cat, and there's my done. If I add something in here, let's see, horse. Now we'll get cat, horse done, because we don't hit dog until the 3rd time through. Does that make sense? There's cat, horse done. Now that's for breakout. Continue with next iteration just says skip this guy. Okay, stay in the loop. Loop keeps going, but skip to the next guy in the loop. All right, so this will go cat, horse, then we'll see a dog, so we're going to say we're going to skip dog, not print it out. And then we'll print out fish. So those cat, horse, fish, done. Make sense? Now what's interesting here is as I'm going through this, I'm promising you that every single one of the things we're seeing here, we are going to learn the Java version of that next semester. Breaks exist in Java, continues exist in Java, all these loops exist in Java. So this is a graphical way of dealing with the exact same languages. Okay, so really a fairly powerful tool. And getting back to what I said earlier, this isn't the thing you want to use to teach like an 8-year-old how to program. You can get into a lot of cool stuff with this. Okay, so that's our loops. Then we get into math stuff. So math, we have just numbers. We can do addition and things like that. We have square root, absolute value. We can negate something, the natural log, the base 10 log, so on and so forth. So a bunch of math crap. We have trigonometry stuff, sine, cosine, tangent, all that junk. A bunch of constants, so pi, I don't know what that dude is. What is that guy? It's written very funny. Gamma, delta, epsilon, zeta, eta, theta. Is that eta? Iota, kappa. Anybody in here know? I know the Greek alphabet, but alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau. Maybe that's tau. Phi, chi, psi, omega. I have no idea what that is. This is pi. So that's what that guy is. So here we'll print out pi here instead of I. That'll be fun. So we'll run this. So there's our pi. There's pi again. There's pi again, and now we're done. Okay. So that guy's pi. The other one is the exponent. Was that 2.73? Dealy flippy. I haven't had math in years. Yeah, 2.718. That's not bad. The number of years I haven't had math. All right. Yeah, do we just want to print out this constant and see what it is? Maybe we'll recognize it by the number. 1.61?
It's phi.
Huh? Phi? Okay. Do we know what that stands for? Oh, yeah. That's very interesting. Why would we need that? Actually, that's kind of interesting. Do you learn about that here on campus in maybe like a biology course? Okay. I'm just thinking from a Christian worldview perspective. The one of the things they use for proof of creation is that golden ratio thing where like certain things have like the petals on flowers follow this exact thing, all sorts of stuff like that. So it's the anti-evolution type of approach. That's a Christian worldview point right there if I've ever seen one. All right, square root stuff, blah, blah, blah. That's infinity. Let's see what happens if we print out infinity. Oh, just the word infinity. That's not fun at all. All right, so in any case, we can test to see something if it's even, odd, prime, whole, positive, negative, or divisible by something. Pretty powerful stuff. Think about the divisible by thing, for our converting for binary numbers, that kind of stuff. Okay, I wonder when you're going to be assigned that. Okay, we can certainly round something, round up, round down. I'm guessing just round just does it the right way. So round up is the same thing as round. Round down just forces it to truncate. I don't know why they just didn't have to round and truncate, but whatever. We can sum up a list of things. I wonder what happens if we sum up the list cat, horse, dog, fish. We're going to sum variable my list. Let's just get rid of this guy here. I can't connect that anywhere. Maybe just print. Yeah. And then print can connect there. So we'll create our list, then we'll print the sum of cat, horse, dog, fish. I don't know what we're expecting out of that. Oh, just concatenates it together. And you know what? Actually, that's an interesting thing. I'll just pretend like I did it on purpose. Because this converts it to JavaScript. And remember, what's actually running here, it's not running our Blockley code, it's running JavaScript. In JavaScript, here's our list. The plus sign, just like in Java, we'll be learning about this next semester. Remember the dot symbol in Game Salad for concatenation? The plus sign in Java, JavaScript, in most of our modern languages, that plus sign, its job is to glue multiple things together if you're dealing with strings. Its job is to add stuff if we're dealing with numbers. All right? So what's happening here is the code is assuming it's going to be adding numbers together. But since X is actually a string and Y is actually a string, JavaScript is treating that plus sign as concatenation. Blockley doesn't have control over it because the Blockley program is not what's getting executed. It's getting converted into the equivalent JavaScript, and the JavaScript is getting executed. That makes sense? So that's why it's just gluing them all together, because since these both are strings, the plus sign is treated as the concatenation operator. In Python, this will be actually interesting to see the difference in the behavior in Python. I'm not sure what happens if we try to sum up a list of strings in Python. Let's try it. So I'm going to grab this code, because notice the code here in Python is different. There's an automatic thing in here called sum in Python. And I'm not sure what the behavior is if you pass it a list of strings. So let's go out here. Yeah, we get an error. Okay, so exact same Blockley code. One of them produces JavaScript that treats the plus sign as concatenation. The other one produces the Python code that doesn't use the plus sign. Instead, it uses the Python's built-in sum function. And that sum function expects your list to be numbers. So if I come back into my code here, and I change our cat, ooh, hello. I just changed this thing to 1, 2, 3, 4, something like that. Give it some numbers. And then I sum those. Row. Let's put operand type for plus, int, and string. Oh. Yeah, the problem is I'm not, I need to do it this way. We're just kind of breaking the list syntax. A list in Python looks like that, where the split function, splitting on the comma, produces that list for us, but it still produced the list that was the string 1, the string 2, the string 3, the string 4. So there's our 10. All right, so we had to modify the code a little bit, but at least we're seeing that it doesn't necessarily produce the same results for all the output languages. Make sense? That's actually kind of an interesting example there. I'm glad I thought of it. I'll definitely do it next time I teach this class. I'll do it on purpose that time. All right, so in any case, that's our lists. So we can create a list. We can ask what the length of a list is and print that out. We can determine if a list is empty. This would be a Boolean. We can check to see if something's in the list. Make a list with our things. We have color spelled the British way. Is that right? Why did they spell it differently? That's just strange, isn't it? It's actually related to something really funny I said in the networking class on Monday. We have a couple of students that are doing a study abroad program from their country. So they're from Brazil. And if you're in Brazil, you spell Brazil B-R-A-S-I-L. So I was teasing them about it when I walked by. I said, why don't you guys just spell it like we do? It's their country, and kind of funny. Yeah, this is strange. Okay, so what happens if I just try to print a color? Oh, print a color gives you the hexadecimal value for that color. Actually, not that, that's probably fairly handy. You could just pick one of these colors if you're an HTML programmer and you need one of the hexadecimal values for the color. There's websites you can go to and just look at a zillion different things. But if you want the hexadecimal value of that blue, there it is. You can just copy it and put it into your HTML code. already uses for Blockley, see? All right. So this would produce a color that deals with the red, green, blue saturation. Each of these numbers would be a number between 0 and 255. We can blend colors together, giving us, I guess, a ratio. That's probably some stuff that I'm not going to spend a whole lot of time on because I'm not a graphics person. Again, we saw variables, so we have we can define a variable up here, but we can also change the value of a variable. So we give it the ability to set a variable to something new if we're creating a brand new variable, or we can change the value of an existing variable, i.e. make it vary. We have our functions, so now we can actually create a function to do something. So for example, if I want to create a function to calculate factorial, something like that. Okay, calculate factorial, we're going to go ahead and we're going to create a variable. Actually, let's do it this way. We'll have this guy take in an input. And the input name is going to be val. Okay. So when we calculate factorial, it'll take in a value, and what we're going to do is we're going to calculate the factorial of that value. So, for instance, 4 factorial is 4 times 3 times 2 times 1. Okay? And we sum it all up. So what we'll do in here, we'll go ahead and set, we can go ahead, that's val there. So we're going to rename this guy to num. And we'll start num off. Under math is our numbers. We'll start this guy off at 1. I know I'm running short on time here. Well, so before I forget, so we've done a bunch of stuff here. What I want you to do for next Wednesday, so you should have plenty of time even if you want to take the weekend off for Easter and all that stuff. For next Wednesday, use Blockley. I'll put the assignment up and I'll give you the link. Use Blockley to go ahead and calculate the binary version of a number. I'm going to finish doing this for the recording just so you see how a function works. You don't have to write it in a function if you don't want. You can just hard code a number 5. Just set a variable equal to 5 and then go through the loop that will generate and ultimately print the binary equivalent of that. That make sense? Just to kind of get used to using Blockley. That's due on Wednesday of next week. So if you want to wait till you come back on Tuesday, you should have enough time to do it. Okay? Questions, comments, concerns, bribes. If you're traveling somewhere over Easter, travel safely, and I will see you on Wednesday, correct? No class Friday, right? All right. One.
Yeah, class, I look over and think, oh yeah, that's due sometime, isn't it? We had a class tomorrow morning, so
The form I have to get for you to sign to take the class online, is that something I'll find in the registrar's office?
Yeah, registrar will have it.
Okay.
Yep. Did you try just registering for the class?
Yeah.
And it yelled about the conflict. Yeah, just get it from the registrar's office and fill it out and I'll sign it.
Okay, sounds good.
Yep.
Lunch?
Yes.
Cool.
Let me just finish writing this real quick. You can be my student while I'm writing it.
What?
You can be my student while I'm writing it, just so I have it for the video. All right, so you paying attention?
Yeah, I'm paying attention.
All right.
It's not like we take this and
All right. So, well, no, but this is the Blockley way of doing functions.
I noticed that when the last class when they brought this up, I was like, this is literally the same exact thing.
It's slick. So calculate factorial. We're going to take in val as a parameter. We're going to start off, I'm going to create a local variable called num. Start off at 1. We're going to repeat until, and I actually need my logic here, until val is equal to 1. So what we're going to do is count down val. So val is 4. We're going to go from 4 to 3 to 2 to 1, and we'll stop. Each time through, what are we going to do? We're going to set num, it's actually this guy, equal to whatever num is currently equal to. Should we need this guy? Whatever num is currently equal to times val. Isn't this really slick? Look at this. This is Blockley. It's from Google. It's graphical programming. So we're using that and comparing it to game salad. Isn't this slick? I'm writing the factorial function here.
Why? Yeah, I mean, you know, there's a similar kind of Mindstorm says similar things. A couple other people do too. But
Is it a completely like full-fledged language?
No, it's a full-fledged language, but the constraints are much more than this.
Okay, I mean this has like everything in it.
Yeah.
It's really cool.
Yeah.
So num to num times val, then
Java, but
we're gonna set
it gives you everything already. You just gotta put it in.
val
Isn't it?
to val minus 1.
It's like so much easier than Java. But I think Java is so much.
Mhm.
Yeah, that kind of reminds me of that, but Scratch is really simple.
All right, and now do we just call it? Okay, I'm going to print it each time. Can I print? I'm printing num. And that's going to go after the loop there. So that's calculate factorial. But now I have to call that function, right? This won't just get called on its own. All right, so now I need to print calculate factorial. Oh, I'm just calling it. With val.
I wonder if it'll actually, if there's a way
Or
you can take off all these graphics and it'll show you what the codes are.
does right here.
Yep. Oh.
It's the Python version. Weren't you paying attention in class? I was running the code over here.
I really was not paying attention at all.
What is it?
I pay attention a lot.
200.
I think it's 200. Yeah. Oh, thank you.
I do. I pay attention in your
That's
class.
good.
With him, I don't.
What?
Yeah, Mr. I
Stop it. Start paying attention to him. Okay? It's important. You could learn a lot. The guy is phenomenal.
I pay. You know what I do? Pay attention in 300.
Oh, okay.
But 200.
Wait, you're taking 200, 300?
I know,
Why are we
seriously, it's
doing
completely
this?
ridiculous.
That's ridiculous.
He took 250 last semester.
I took 325 before I even took 200.
All right, so there's
Hopefully you
that.
didn't pass.
I got a D plus.
So
Okay.
how do I print that?
That's fair.
How do
Yeah, I
I
don't know how you're supposed to connect that. Yeah.
print?
So I would like to ask you a question.
No, you keep working on that. But Mike, will you wander by me before you wander away?
Yeah. I'm going to have this figured out in 2 minutes. You going to lunch with us?
Faster than I don't know you.
Okay, so this will calculate the factorial.
You buy it?
I'm fine.
Variable.
You gonna come?
Functions.
I was just going to ask you about homework.
I took a look at it yesterday. I had no idea what I was doing. So I never
Look at
had
this and let me know what you think. I'm going to go log out.
I mean, here I can test this in Python just to make sure our logic's good. It should be. Oh, you can't keep up with my awesomeness. There's that. There's that.
You're going so fast, you're taking it like so seriously.
So I'm going to print. Boom! All right, so this 4 times 3 is, okay, yep. I'm going to just print the result of this.
Next step equals this. One. I love how you're giving this to me like I understand.
All right, so our logic works, because there's the solution in Python. But how do I actually print?
It looks good.
I don't know.
But there's like, I know that you haven't.
Yeah, it's not finished yet. But like when I was researching it, there's 4 different things you need to consider. This thing is awesome.
Functions.
It goes through and then you can add them.
Calculate factorial.
And it'll actually show you the animation for how they get added. And like I think this stuff is depth, but they do it in
How
a
did you find
shorter.
this?
Just searching. So it's gonna shift it because it's not both.
Oh, I see. We have to use the return version. There's a version that returns a value. That would, I'm assuming that would change
If you haven't.
this. So I don't have a value to actually return, therefore it's not popping back out. So what I can do here is this is printing num, so this should just work. Yeah, there's 24. Because I'm not receiving the value, I'm just having it print here in the inside. Make sense?
My biggest question is, wouldn't you have to have a little bit of experience with